Well, one of the most active volcanoes in the world sits just a few hundred miles off the U.S. West Coast, and some scientists believe that it's really only a matter of time before it erupts again.
Scientists are sounding the alarm across the Pacific Northwest as Oregon's underwater volcano, Axial Seamount, awakens once more. Deep beneath the gray surface of the Pacific, 480 kilometers off the Oregon coast, an ancient force is building. A force at once hidden and unimaginably powerful. While most of the Northwest shivers through autumn storms and winter squalls, something significant is stirring on the ocean floor. For months, datasets throb with urgency. Researchers race to decode cryptic seismic signals, and emergency management officials at coastal command centers share wary glances over satellite feeds. It is not the weather that troubles them this time, nor the threat of wildfires, nor the dread of coastal flooding. It is the specter of an eruption in the making, one born not of fiery mountain craters, but from the midnight world beneath the Pacific, a place few will ever see firsthand, yet a force with the potential to reshape the region in profound ways. The urgency is unmistakable. For months, live feeds from ocean bottom sensors have captured the telltale signs. The axial seamount is beginning to breathe. Ground deformation, slow but relentless, has lifted the seafloor by centimeters, then inches. Swarms of tiny earthquakes, hundreds each day, pulse through ancient lava fields. And while headlines reassure that no imminent tsunami threat looms, inside the Pacific Seafloor Observatory, anxiety simmers. There is apprehension, rooted in uncertainty, in the raw, untested energy gathering beneath a silent sea. Yet among geologists and volcanologists, awe mingles with caution. The possible scale of an undersea eruption, quiet enough to mask its violence from view, yet powerful enough to ripple through the tectonic fabric of the entire Pacific Northwest, commands respect and vigilance. Emotion, too, runs high in Oregon's coastal communities. Fishermen, who know the ocean's moods through instinct, sense that something is different. Scientists stationed at Coast Guard bases quietly debate the potential for dangerous earthquakes, not because the volcano itself likely threatens the towns above, but because forces stirring below could reverberate across fault lines mapped in uneasy red ink. Infrastructure managers recall past disasters as they update emergency protocols, knowing this warning is not simply routine. The danger is not simply a growing force in darkness. It is uncertainty, multiplying with every new reading. Where does this end? Is the awakening of a volcano merely a beginning for deeper, unforeseen threats? The danger stops not here. What most people can see, the swirling clouds, the restless surface of the sea, the shifting moods of the coast, is only the opening act of a massive, unseen drama unfolding below. The axial seamount does not rear its head like Mount St. Helens. It does not send fire and ash into the sky above Portland, or paint sunsets with volcanic dust. Instead, its danger seeps upward from the benthic world, invisible to daylight, revealed only in seismic charts and live data. While the surface remains tranquil, a slow inflation is lifting the sea floor. Pressure is mounting inside ancient chambers. Magma is inching toward fracture lines, and every pulse hints at an eruption yet to unfold. But the danger is not limited to explosions or torrents of lava. In truth, the real uncertainty is the potential chain reaction, which scientific models struggle to quantify, where an eruption could redistribute stress underground, possibly affecting nearby faults. While direct causation remains scientifically debated, any additional stress on tectonic plates in the Pacific Northwest is a concern for seismic hazard planners. Beneath the apparent calm, it is pressure, slow, implacable, and rising on a geological clock. Each new set of data amplifies the sense of uncertainty within the Pacific Northwest research community. Scientists no longer simply ask if, but when. The question echoing in research vessels and emergency briefings now is chilling. What could follow if Axial truly erupts? Could the awakening of this volcano act as a catalyst for a major earthquake? And if so, how can coastal communities prepare for a rare but high-consequence risk? The scientific answer remains complex and in many ways unsettled. Researchers are cautious to clarify. Axial's eruptions, while dramatic, have historically not triggered large earthquakes or tsunamis that endanger coastlines. Still, the nervous energy swirling around the question is real. This volcano's slow charging is not merely an eruption threat. It operates within the broader tectonic context of the Pacific Northwest's Ring of Fire. As magma rises and pressure deforms the crust, regional stress is redistributed. In a region already defined by significant seismic risk, any uptick in underlying pressure carries consequences that demand attention. Subscribe to our channel now for continuous updates as this story unfolds, and join the discussion to help decode the events shaping Oregon's coastline. While the clock ticks beneath the waves, let's dive deeper into what is unfolding, why Axial Seamount has scientists' full attention, and why the months ahead may become a turning point for the Pacific Northwest. It begins with a silence so deep that only the most sensitive instruments, deployed years ago on the seabed, can hear it. 480 kilometers from Oregon's edge, Axial Seamount is an oceanic giant whose rhythms are measured in slow, relentless cycles. Over the past year, teams led by Dr. Thomas Hildebrand at the Pacific Seafloor Observatory have observed uncanny changes. Minute but persistent swelling of the crust, visible only in precise satellite measurements. Ground deformation, the experts call it, a geologic prelude that rarely lies. For those less familiar with volcanic science, imagine the ocean floor as a restless stage, rising and falling in deep, slow breaths. Each inflation of axial seamount means magma is pushing upward, inflating the Earth from within. This process, methodical and unstoppable, is less like a sudden storm and more like a pressure cooker, building quietly, step by step. Over centuries, the volcano rises and falls, each pulse accumulating until a threshold is crossed. Seismic data, though complex, tells a stark story. Hundreds of small tremors echo the journey of molten rock through cracks and faults. To the untrained eye, these charts might seem random, but to experts like Dr. Hildebrand, each spike is a landmark, evidence that the volcano is mobilizing. In recent months, the frequency and intensity of these microquakes have multiplied, suggesting the system is approaching a critical point. Yet despite decades of monitoring, scientists can only estimate when Axial will erupt. Past eruptions, most recently in 1998, 2011, and 2015, were well forecasted by patterns of uplift and earthquakes like those being observed now, but never down to the exact week or month. Today's signals rank among the strongest recorded in a decade, yet remain within the envelope of past behavior. There is no ash in the sky, no falling stones, only charts and graphs pointing to the possibility of imminent change. But here, the risk takes a different form. Axial stirrings stretch their influence along fissures and fractures shaped by the region's complex tectonics, including the Juan de Fuca plate and the infamous Cascadia Subduction Zone. This is the silent threat that an eruption could transfer stress, perhaps imperceptibly, to a fault already prone to rupture. So what exactly is brewing on the Pacific floor right now? And can careful observation help predict, if not prevent, the next step? By mid-2025, sensors ringing Axial Seamount were sending back data that heightened concern in Oregon's marine science community. Pressure sensors, tiltometers, and underwater microphones, hydrophones, all showed the same narrative. The ground was rising, and small quakes were occurring with greater frequency. These are the harbingers researchers watch for before undersea volcanic eruptions. In August, a notable spike in seismicity triggered alerts at research stations along the Oregon coast. Oceanographer Dr. Lena Kozlovsky and her team at the Newport Marine Lab double and triple-checked the readings. Axial's inflation rate had accelerated, Data patterns matched those observed before past eruptions, though each episode is unique. Dr. Kozlowski warned, if this rate of ground rise continues, we could see an eruption by the end of the year. Although the eruption itself may not threaten people directly, its consequences reach further. What could that mean for the Oregon coast? An eruption at Axial is not expected to cause significant tsunami risk or directly threaten lives ashore, given its remote location and the nature of undersea eruptions, which often emit little energy vertically toward the surface compared to massive, shallow earthquakes. Marine life near the site, especially species adapted to hydrothermal vents, may be displaced or affected by new lava flows and hot fluids. The biggest concern for coastal residents, and indeed for preparedness planners, is the region's overall seismic vulnerability. The possibility, however remote, that the redistribution of underground stress might set the stage for a larger earthquake. Here, the language becomes more urgent as the magnitude of compounded events is considered. A megaquake along the Cascadia Subduction Zone, estimated to occur every few centuries, would begin not with an explosion, but with a subtle slip along a vast fault line. Scientific consensus holds that such quakes are inevitable, but their direct connection to volcanic eruptions, like those at Axial, is still under study and debate. Most models suggest the risk of a direct trigger is low, but scientists are vigilant for any correlation. So, as the microquakes continue and the ground keeps rising, what follows next? And have lessons from past episodes adequately prepared us for the unique blend of hazards the Pacific Northwest faces? Subscribe now if you want to stay 2 steps ahead of the world's changing coastlines. Your engagement helps us enhance our coverage as events develop. For outsiders, the Axial Seamount's eruption may sound like an isolated event, a distant spectacle of underwater fire. But for scientists and emergency managers, every jolt and shift is a piece of a much larger puzzle. The Pacific Northwest is a region defined by compound hazards, volcanic energy, tectonic movement, ocean dynamics, and vulnerable infrastructure converge in ways that amplify risk. As Axial inflates, it increases pressure along fractures near the boundary of the Juan de Fuca and North American plates. While the incremental stress added by an underwater eruption is likely modest compared to the long-term forces driving plate movements, the intricate web connecting volcanic and earthquake hazards cannot be dismissed. Coastal land here is not only eroding from above, but slowly subsiding from below, a process tracked diligently by geologists. Sinking ground accelerates the impact of extreme floods and storm surges, turning what once were rare hazards into more frequent threats. Historical records offer warnings, but rarely simple answers. No prediction model can fully account for the interplay among seismic energy, undersea eruption, and land subsidence. Our defenses, as one geologist noted, were not built with these compounded threats in mind. That's the challenge we face. When hazards align unexpectedly, even well-practiced emergency protocols can be tested to their limits. The next great quake or eruption, even if still years away, could challenge Oregon and the entire West Coast in ways not seen in living memory. Can real-time data and planning buy precious minutes? Or are some outcomes beyond the boundaries of human preparedness? When researchers describe the Cascadia Subduction Zone as loaded, they mean it quite literally. Stress has been accruing underground for centuries. In this delicate setting, each seismic or volcanic event changes the regional stress field, a phenomenon that is the subject of ongoing scientific inquiry. Should Axial erupt, the associated stress changes would mostly remain local. But any shift within a plate boundary system so extensive and complex as the Cascadia could, in theory, affect the timing of a large earthquake. However, the idea that an axial eruption could trigger a megathrust quake remains speculative. Ongoing research by seismologists is monitoring the faults for even subtle interactions, while acknowledging that deep faults are more likely to be influenced by the slow, relentless forces of plate tectonics rather than any single volcanic outburst. That said, the broader hazards of a megaquake are very real and regularly rehearsed by emergency officials up and down the coast. Should such an event occur, regardless of why, the resulting chain of disruptions would likely stretch far beyond the coast, affecting energy grids, transportation routes, communication networks, and water supplies. Landslides and flooding could follow, further isolating affected communities, as bridges, roads, and pipelines are vulnerable to ground failure and liquefaction. If multiple hazards align, volcanic, seismic, meteorological, standard preparedness models can break down. The margin for error narrows, and the importance of timely warnings and clear communication rises dramatically. Could this rare convergence, an awakened undersea volcano, a loaded fault line, vulnerable land, signal new complexities for the Pacific Northwest? Every tremor logged by seafloor sensors and each new deformational scan adds urgency for researchers monitoring axial seamount. At the heart of their concern is not a lack of knowledge, but the realization that prediction has real limits. Volcanoes and earthquakes interact within a vast, complex system, one that pushes the boundaries of even the best scientific models. The axial seamount has erupted several times in the past 30 years, sometimes with impressive energies. But the current signals, accelerated uplift, frequent low-level earthquakes, are more pronounced than in recent years and demand vigilance. Still, patterns from past events are incomplete guides. No eruption follows precisely the same script. To complicate matters, regional risk profiles are evolving. Marine heat waves are changing ocean chemistry and affecting the strength and behavior of underwater eruptions. New patterns in hydrothermal venting alter the mechanical properties of seafloor basalt, and small shifts in rock structure may determine whether future eruptions remain contained or breed new crustal instabilities. Oregon's infrastructure, tested over the years by storms, erosion, and slow landslides, faces increased strain in a future shaped by both natural and human-driven changes. As Dr. Jean-Paul Marceau recently put it, we can adapt and plan, but if events exceed historical limits, even our best efforts may be overwhelmed. Science is powerful, not omnipotent. What matters now is a culture of readiness, knowing when to evacuate, how to secure lifelines, and when to take warnings seriously, even if the immediate threat appears remote. When data blurs into uncertainty, who decides what level of danger is too large to ignore? As autumn rains lash the beaches and tides surge against Oregon's jetties, daily life persists. Schools open, fishermen test the waves, and city councils debate budgets. Yet beneath the ordinary beats a different awareness. From Astoria to Newport, coastal families follow every seismic update, seeking clarity, or, at the least, a better sense of timing. There is no panic, yet tension is palpable. Emergency kits are discussed anew. Parents plan alternate routes. School boards debate protocols for sheltering in place. Networks, built for wildfire or storms, adapt to test communications should a megaquake or major eruption occur. Recent years have already shown the grid's vulnerability to flooding and saltwater, an issue amplified in any compound hazard event. Along the shifting shoreline, local researcher Dr. Becky Mercado notes how the coast is always on the move, even absent major disasters. Minor land loss is routine, until one day a single event redraws the map in hours, not centuries. Satellite imagery at recent community meetings has made the theoretical immediate. Ground in some coastal areas has sunk by millimeters per year. In the context of Axial's current activity, every new centimeter matters. As the likelihood of an eruption grows, flood maps and emergency plans are redrawn in real time, their boundaries shifting with each scientific update. How prepared are the towns and cities of coastal Oregon if a chain reaction of events were to begin invisibly but end with a coastline transformed? Nightfall brings little rest to the scientists and technicians staffing Oregon's ocean observatories. As shadows stretch across the Pacific, the seamount churns, not with sudden drama, but with steady, persistent warning. Each hour may bring new signs: a tremor spike, a deformation surge, a magnetic anomaly. Dr. Kozlovsky's lab runs round-the-clock models, testing scenarios for eruption, earthquake, and infrastructure failure. Their predictions fog and refocus as new uncertainties surface. Some scenarios put an eruption weeks away or months distant. Others suggest a false calm as the volcano builds quietly toward its own schedule. Still, the warnings grow sharper. For the first time, state emergency bulletins mention the Cascadia connection, acknowledging, albeit cautiously, the risk that an undersea eruption could add complexity to regional hazards. The real threat is not simply lava or ash, but the potential for a series of domino effects, small shifts adding up to major consequences. Urgent messages circulate, from research labs to emergency planners. The question that once seemed remote now centers every meeting. How do we respond if this is truly the beginning of a major event? What is the cost in lives and legacy if we wait for absolute certainty before acting? As dawn rises over coastal Oregon, the region sits atop a restless, slumbering beast. There is hope, found in science, vigilance, and planning, that the worst can be mitigated. There is resolve, rooted in uncertainty, to prepare despite imperfect forecasts. Here is the reality. Oregon's underwater volcano is awakening. As axial seamount inflates and seismic signals increase, the region stands at a crossroads between complacency and preparedness. Every day, researchers like Dr. Hildebrand, Dr. Kozlovsky, Dr. Marceau, Dr. Mercado, and others thread the line between warning and reassurance. Their message is clear. Preparation now is our best defense. For events unfolding in the ocean's depths have the power to change everything above in a night. Communities that survive are those that treat scientific warning as the drumbeat for action. As the world waits, as pressure builds beneath the waves, the Pacific Northwest's story may soon be written not in headlines or speculation, but in hard choices and swift responses. What questions do you have? Have you begun preparing your own safety plan? Will this time be the moment when Oregon's readiness is truly put to the test? Subscribe for updates and join the discussion below. As the mysteries of the Pacific unfold, we'll be here to track them, one seismic tremor at a time.